welcome back to the Troutman Pepper Battery and Storage Podcast. I'm your host, Bill Derasmo, and today we're very excited to have Michael Niggli, the chairman of the board of ESS Inc., as our guest. Welcome to the podcast, Mike.
Thank you, Bill. Looking forward to today's discussion, especially on a great new technology coming into the marketplace.
Well, absolutely. Well, I'll just talk about you briefly and brag on you a little bit because you've had a tremendous career in the energy industry. You're currently chairman of the board of ESS Inc., as I mentioned, which we will get into in detail on this podcast, a long-duration energy storage company. But previously, you served for many years as president and CEO of San Diego Gas and Electric Company, president of Sempra Generation, the chairman of the board, CEO, and president of Nevada Power Company, the chairman of the board, CEO, and president of Sierra Pacific Resources, which is now NV Energy, and the CEO of Southern California Gas Company, and you were also a senior officer with Entergy Corporation. You've provided expert testimony in many jurisdictions. You're very knowledgeable about the industry overall, obviously, with all of those varied experiences and high-level corporate experience. You're currently serving not only on the board of ESS, but ATC and several other companies, and then also charitable and nonprofit boards. So we really appreciate you bringing a wealth of experience to the discussion today. That being said, we do want to have some focus on your iron flow long-duration battery company, ESS Inc., which ESS Inc. is also going to be going public as well. So we might talk about that a little bit. But Mike, why don't I turn it over to you, and maybe you could just give us a little bit of an introduction about ESS Inc., and then we could start diving into maybe some more specific questions.
Sure, I would be glad to. Thank you, Bill. First of all, what's interesting about iron flow batteries is they've been around a long, long time. And the great thing about what's happening in this last decade is that this company, ESS, which was founded by Craig Evans and Julia Song, Dr. Julia Song, about 10 years ago, they started focusing on the issues of how do you bring a product like this to commercial reality. And they have been working very, very hard on that for the last 10 years and have put together over 125 patents on the technology and advanced it to the point where we now have a commercial opportunity to bring a new solution to long duration storage for the marketplace. And we are rolling that out with our SPAC transaction that was recently announced. And with that SPAC transaction, the company has a value of over $1 billion. The exciting part of this, frankly, is from my standpoint, where I've been in the energy industry for a long time, is that we're bringing a solution to what people often call the holy grail of renewable energy. Renewable energy needs to have a way to be controlled and distributed into the grid when it's needed. It's not always needed necessarily in only the middle of the day, as the solar curve would suggest, or when the wind is blowing. But what we're finding is that the opportunity for long duration storage is rapidly emerging. And we define long duration storage as durations of storage that are anywhere from 4 to about 12 hours duration. Our technology has that kind of a sweet spot from 4 to 12 hours. And we've got a number of features of our technology that are probably going to be of interest to a tremendously wide array of market segments. The big 4 features we like to think about are unlimited cycling, zero degradation, a very long life, and low cost of service and ownership. Those 4 features are the kinds of features that will find their way into almost any application that you will find. From the standpoint of unlimited cycling, when customers have the ability to cycle multiple times a day, it eliminates many of the restrictions that you have in today's battery systems. When you have zero degradation, it gives you a lifetime that is on the order of 25 years with a substantive terminal value at the end of that period. And when you can get the low cost of ownership of the product, then the margins and the profitability for our customers improve throughout the utilization of their technologies. So I guess what I would say with this, Bill, is as we get started on our discussion, is that these four big features are sort of the heart of our very simple system that has iron, water, and salt as an electrolyte that essentially is utilized to store and then deliver the energy from the system. I would add one last thing is in terms of sort of the features of the technology. Every time we talk to customers, we find that they actually define what are the most important features to them. For instance, we use no hazardous chemicals, zero hazardous chemicals. Now what that means is you have no risk of explosion. You have really no risk of fire from our equipment, and we utilize earth-abundant materials. So in this day and age of ESG heightened awareness, we're finding that many customers see the ability to have these features as being important. And another one is we're American made.
Oh yeah, then that's a big one. And the reason why I jump in with that one is obviously the events over the last couple of years, but really coming into focus within the last year on supply chain. And you had some actions by the Trump administration in there towards the end of that tenure. But recently you've got, I think, the Biden administration issuing a blueprint for lithium-ion batteries. But really, if you look at what the Department of Energy has put out, it's really focused on securing the supply chain and bringing battery capability basically back to the United States to the extent it isn't already here. So there's definitely a focus on that last point. But I want to switch gears before we get to that stuff more. I want to talk about the iron flow technology because it's really interesting when you look through the materials on ESS, because there's been such a growth in the lithium-ion space, but now you've got long-duration companies starting to emerge like yours, and you've talked about all the benefits. So what is it special about the electrolyte, which is, as you say, iron-based, that differentiates it in the marketplace, and why companies that are putting out RFPs for storage would take a close look at this chemistry?
Yeah, that's actually a great question, because one of the critical challenges we find in our business is that it's really about market education. And lithium-ion has been a tremendous success over the past decade in meeting some of the shorter duration applications from ancillary services to 1 to 2 hour all the way up to 4 hour applications. And it's become the standard for most of the marketplace. And then along comes a technology like this that actually is lower cost at 4 hours and allows you to get a massive cost benefit for anything that goes from 4 to 12 hours versus lithium. And I think what we see too with on the bigger picture, lithium is generally going to be targeted towards electric vehicles and some of the smaller appliances, applications like that. Whereas what we're targeting is a completely, a segment of the marketplace that is the larger segment, the grid applications, the large commercial and industrial customers who need long duration services. And so we now essentially are telling the marketplace that, yes, there is something that exists that will meet those demands. And the intriguing thing about iron, salt, and water is it's a simple system. I think that's probably one of the most important characteristics, is that it is simple and straightforward, and we can separate the power from the energy side. So if you want a certain amount of power at 4 hour duration, we can do that. If you want the same amount of power at 8 or 10 or 12 hour duration, we can do that. And our costs go down rapidly as you expand the duration. I would say on the aspect of iron, salt, and water is that we do utilize, of course, earth-abundant materials, iron's just about everywhere. And when you think about the government's focus on a blueprint for lithium so they can shore up the supply chain, you probably won't see a blueprint for iron. You're not going to see a blueprint for ESS's technology because we're straightforward and we can get this just about everywhere. So we're not expecting any kind of shortages for the basics of our product. And I guess the last thing I would say is that our product is so benign that it has a pH of around 4, so it's nothing that's going to cause any problems with any of the materials it comes in contact with. We even had one customer, interesting story, early research customer that put the device, tested it right next to a very, very old oak tree in a winery area. And we asked them why they put it there, and they said, well, if your product ever had a problem, it's just like fertilizer. And so it can grow essentially in that area. So you don't have any hazardous materials that you've got to worry about here. And that's one of the keys with our product as well.
Well, Mike, quite simply, you probably don't need a blueprint for it. It's just not necessary, right? If it's an earth-abundant material, then you just don't have a need for that kind of shoring up the supply chain effort. It's already here, and it's not an issue, it sounds like. And you got your facility where you produce your system. Why don't you tell me about that? Because we started out mentioning the issue of the fact that you guys operate here in the United States.
Yes, that's absolutely correct. And this is the proverbial, garage story success that has happened here. When Craig and Julia started the company 10 years ago, they were in a garage, and now we have 150,000 square feet of warehouse capability and manufacturing capability in the Wilsonville, Oregon area. And this allows us to manufacture all of our facilities, all of our products at that particular facility. We are ramping up right now from about 250 megawatt hours per year to about 2 gigawatt hours. And one of the features of this simplistic technology is that we can add additional capacity at a fraction of the cost that the lithium-ion providers have to pay to establish their new factories. And so the really key point here is we can continue to add on in Oregon inexpensively, or we can take our footprint of our production cells and put them in other locations around the world, which just continues to reduce shipping costs for our products. So this American-made product has the ability to go to lots of different places and supply needs in many different parts of the world. And as we have talked to customers in various areas around the world, they're coming up with applications that possibly we did not even see here. So the market segments continue to grow.
Well, Mike, it sounds like you guys have a modular product that can be installed easily anywhere in the world, and that has to be attractive to customers. It doesn't, based on the materials you sent me, it doesn't have a large footprint, and based on all the things that it can do, is a very adaptable solution. And so I think that as we go forward and we start seeing more RFPs issued, I think you're going to start seeing a point of entry for the long duration solutions to come into focus more and more. But why don't you tell me about one RFP that you guys already were successful in? That was you mentioned a South American RFP.
Yes, I'd be glad to. And in fact, Bill, what we're finding on the inflection point that's coming for long duration storage is it's happening right now, and it's happening faster than we had anticipated. And the reason I say that is almost every RFP that we've seen over I guess I would call it the first 8 or 10 years of energy storage were less than 4 hours, most of them in the 1 to 2 hour stage. And just in this last 12 months, we've started to see a big jump in RFPs from 8, 10 to 12 hours in various parts of the world for different kinds of applications. One of the applications in South America, which was very, very interesting, was with a utility that had a remote grid. And this particular remote grid was something they put an RFP out for 2 hours for a lithium battery. And we told them, we said, well, we're going to bid a non-conforming bid. And they said, well, why would you do that? And we said, well, we have a product that will give you better economics, will be more reliable and longer lived, and pretty much match your utility asset life of service that you really look for. And so we provided a bid to them, and ultimately they selected our product that is nearly a 7-hour duration product, and it's a modular product that we can bring down and put into this remote area. It actually can act as a microgrid. It has hydroelectric services and diesel, and they have to operate the diesel all the time during the year. And our product will allow them to take the excess hydro, store it, and reduce their diesel consumption rather substantially. So that's an indication of where, when the marketplace gets educated, they can find tremendous uses for it. I think what we're also finding is that whenever you want to shift solar energy, that the solar curve is not a 4-hour curve, and you can take any slice of that solar curve and utilize it to shift into other periods of time. So whether you've got a 4, 5, or 8-hour demand period, such as we do see in some areas of the southeast of the United States, you can actually shift energy, whether it's from wind or from solar, into the time period where it's needed. And then just recently, there's been a tremendous number of inquiries that we're getting in 2 particular areas. One is the potential for producing green hydrogen. And when we say green hydrogen, we mean completely utilizing renewable power. And again, that's whether it's cyclical wind or it's solar power. We can absorb all of that and then distribute it over a 12-hour nighttime period. So we allow the electrolyzers on potential hydrogen projects to operate in the way they want to, 24 hours a day, 7 days a week, all the time, to get the most economy of scale. One other very interesting application we're seeing is in the area of EV charging, especially for large fleets, and also distributed in various parts of highway systems. We're seeing a lot of interest in the fact that we have unlimited cycling. So some of these companies are looking at flash charging, but they really need to be in a situation where they can have unlimited cycling, and we provide that capability here with our products. So we're seeing those kind of cycles or use cases come up right now. We're also seeing a number of use cases where folks are looking at not only shifting peaks, but supporting the grid. And because we have unlimited cycling, you can essentially get ancillary services for free. And so people are looking at, when they're not cycling their product or the storage facility, they can support ancillary services on the grid. So it's a lot of a very complementary opportunities where people can stack revenue and stack effective use cases.
That's amazing to hear. I mean, one of the things we've talked about from the beginning on this podcast is, that last point, how do you stack these services and monetize them? The other thing that we've talked about is the customizability of storage solutions, and it sounds like ESS obviously has that in spades. I mean, you can be customizable in so many different ways. Just a quick anecdote, I was talking with one of my colleagues, and we're talking about the challenges of contracting for these, this is on the legal side, contracting for these storage solutions. And, his impression was that, and it's mine as well, is that right now everyone's still figuring things out, but it runs the gamut from highly customizable contracted for services on the one extreme, and then on the other side, the other extreme, you just have companies that are basically renting a battery and using it's sort of like, okay, we'll give you a capacity payment. We were told we need to go out and procure storage, and we're going to do that, so we're going to rent your battery, and then we'll kind of figure out how we use it. So obviously, I'm not sure I recommend the latter approach, but I think where you guys are, you're on the highly customizable side, and I think that has to be very attractive to potential customers. What you ran through with the South American example with hydro and diesel, and then figuring out a way to optimize that solution, so to speak, in that location. I mean, that's just a great example where it sounds like ESS, you can basically take in whatever the pertinent facts are, whatever the situation is on the ground, and design an optimal solution. And I just think that has to be incredibly attractive, like I said, to potential customers. So, as we go forward, I think it's another trend to look out for on these RFPs is how granular are customers going to get? And if they're not granular, how far can you go, as you say, with a non-conforming bid? So I think those are things that, the lawyers and consultants probably going to spend a lot of time in the coming years thinking about and working through.
Well, we're finding too that the people who are also paying great attention to this are the analytic folks who simulate the utilization of storage with their assets. And as an example, we've had a number of questions about the ability of our systems to sort of grow into the needs of a company. So, for instance, if someone said, "Oh, by the way, we think we need a 4-hour system right now because we're shifting some solar," we say, "Okay, we can come in, and we are generally going to be at or below the cost of ownership of a lithium system for 4 hours." But if you find that your marketplace is changing, which it clearly will over time, and you want an 8-hour system, you don't have to replicate our entire system. All you do is add more electrolyte storage capability, iron, water, and salt. And that is an incredibly inexpensive way to expand the energy capacity of a system. And then if someone says, "Well, we want to go to 12 hours, you just do the same thing there. Or if they say, "By the way, we want to use ancillary services because in our region they now pay for it." And we're seeing this in a lot of countries where people are sort of marching towards they will be willing to pay for ancillary services as well on the grid. They have that as a free capability in our equipment. It's already built in, ready to go. So from that standpoint, I think you'll find that as the analytical folks think carefully about risk management and how to make their assets more valuable in the future, it is an awesome feature that we have with this kind of flexibility to expand your energy capacity at a very, very low cost and to continue to have features. And the other feature, I guess I would say, that's very unusual, especially when you compare it to some of the existing technologies, is that we have a very wide operating temperature range. So typically you can operate our equipment from just below freezing to 125 degrees F without any supplemental heating or cooling for the power modules themselves. And that is a tremendous feature because we're finding many customers in the warmer climates in particular and in the colder climates are finding that they are getting a pretty decent bill for air conditioning or supplemental heating in their facilities, and that's not something you're going to see with us. So it's a very much a factor in those kind of climates where there are some extremes.
Well, great point. And obviously, in light of recent events, the Texas situation and just overall concern about resiliency, that feature is another advantage for ESS, obviously. And I just think in general what you walk through there is something that I haven't heard others talk about, is the ability to change midstream or adapt midstream if your customer finds that they want to alter the solution that they were solving for, that you guys can step in, I guess I would say midstream, and alter the project in a way that sounds very cost effective. So I think those are all attractive features with the iron flow battery and with ESS. Tell me, this is a pet interest of mine. If people who've listened to the podcast know that I'm always interested in primary frequency response or regulation And the history with that in the United States has been a little bit tortured. But you were mentioning if markets or countries are willing to pay for those types of ancillaries, that's something that your product can do. But just tell me for a minute about the iron flow batteries' ability to provide for those types of products.
Yeah, we'd be glad to. The bottom line on it is that we qualify for all ancillary services that are being marketed and are being paid for. So if you want rig up, rig down, frequency control, all of those come with a package. Essentially, we have the capability to support that, and we have that capability on a continuous basis. So if you had an installation with another technology, you would be limited to probably one cycle a day, and that limitation comes in the form of a warranty requirement, or it comes in the form of a limitation on the core temperature of the product, or it comes in the form of you're going to have a much shorter lifetime. We have none of those limitations, and those limitations do not exist with our product, so you can utilize it for ancillary services all day long. It was interesting that you mentioned that the Texas freeze as well, because we went back and did some work for some customers and found out that if you had a 6-hour battery during the Texas freeze, which was 4 or 5 days long, that was the actual sweet spot for making money and also providing services to the Texas grid. You could have provided all the energy services necessary to support the grid, and then also the ancillary services as well. So it was an interesting case study that we looked at.
It's fantastic. And yeah, when you started talking about the temperature issues, of course, the Texas situation jumped to mind. And it sounds like you guys were well positioned to help out the ERCOT, help out the Texas grid, in working through that crisis. Well, let's just shift gears really quickly. We've talked a lot about the battery chemistry, the advantages of iron flow. But let's just talk about your company, ESS. It's an exciting time. You guys are going forward, going public with a SPAC transaction. If you could just talk for a minute in your position as chairman of the board, what's that process been like? You hear a lot about in the financial pages about SPACs, but what has that transformational event been like as you guys try to work through that? And you talked about your founders as well and all the years of work they put in. So I'm sure in the one sense it's gratifying that the company is now entering this phase, and the other sense it might be a little bit nerve-wracking. So if you could just talk about that, I think it'd be interesting to hear.
I'll be glad to. I think there's a couple of critical points that have happened with ESS, and one of them is that we have 10 years of company history, but we've had about 4 years where we had our first research grade projects deployed into the marketplace to prove them out and to continue to develop the product. And utilizing that kind of data and information, we're now beginning to produce our commercial grade facilities out of our factory in Oregon. This sort of came together from a timing standpoint with the proliferation of the SPACs, and we have signed a SPAC with Acon 2, and we're very, very pleased with the principles of that firm and how they have conducted their business and worked with us to make sure that we can be successful in this process. So it came together with the, I guess I would call it the technology maturity, along with the opportunity to put this type of funding into place, combined with the fact that the marketplace is now pivoting towards long duration in a way that we've not seen in the development of the energy storage business. So I think we're in the right place at the right time with the right product, and I think that's something that we're pretty excited about. We brought on a CEO, Eric Dresselhaus, who has previously been through this kind of a space where he was one of the founders of Silver Springs Network, and he brings a tremendous creativity and experience into leading a company into the public sector. So we're we're thrilled to have Eric with us. The other thing I think I would say is that the strength of our investor group was critical to this SPAC process. We have BASF, the world's largest chemical company, as one of our investors. We have Breakthrough Energy Ventures, Bill Gates' Vision Fund. We have SoftBank Energy, one of the larger players in the renewable sector in the world. We have IPM development group out of Europe. We have PTT out of Southeast Asia. We have Evergy right in the heartland of the United States in the utilities sector, and a couple of Canadian venture firms who were very early investors, Cycle Capital and Pangea. So this is just a scattering of the kinds of folks who have funded this technology to this point. When Aecon came to us and was looking at our product, and we were talking with them amongst a number of other SPACs, the critical factor became the differentiation of our product versus anything in the market right now. The differentiation between us and any of the technologies and our readiness to deploy. So those two factors have really driven, I think, the opportunity for the company to go through this. It has been a tremendous lift for our CFO, Amir Moftakhar, and his team as they have prepared all of the financial work that has to be submitted to the SEC. We did announce the transaction in March. We filed our S-4 documentation just in the last couple of weeks, and we're hopeful that as the SEC reviews the materials, that we'll probably get a close late in the third quarter or early in the fourth quarter of this year.
Well, thank you for running through all that, and that is a really interesting array of equity investors that you had, and then to hear the story with Aecon and the fact that you guys are rolling along for a late third quarter, early fourth quarter, sounds like, close on the deal. But opportunity, the opportunity is there, and as you said, the timing, it was the right solution at the right time, and so it's no surprise that you were noticed, that ESS came to be noticed by Aecon, and that they express interest in doing this kind of deal. So certainly a unique type of solution in the marketplace, and a lot of what we talked about, that the RFPs and the solicitations and just folks in the energy space looking at storage solutions, the ship is starting to turn to more than just lithium-ion batteries. And as I said in the past, lithium-ion batteries are great, and they do great things, but there's room in the marketplace for different types of solutions, and certainly the long-duration solution is going to be attractive in a lot more types of applications. So I think, timing is everything. It sounds like you guys are in the right place at the right time. So certainly exciting times for ESS.
The upcoming future here it reminds me of what our parents have often told us is you have to know your 3 R's. And we're thinking about that in terms of ESS, and somebody said, well, 1, we're ramping up. 2, we're ready to roll our commercial scale products. And 3, you can reduce your cost of ownership. And with those 3 R's, you have an opportunity to be successful in the business. So we're looking forward to meeting the challenges of the shifting dynamics towards long duration storage technology. We'll be one of the first in the marketplace with a truly commercial solution that utilizes earth abundant materials, is environmentally friendly, has the lowest global warming footprint of any production cycle for any of the technologies. And we think that these characteristics, along with our technical characteristics, are going to lead us to good opportunities to work with customers to bring their costs down and to deploy the renewable solutions that we're seeing are desired throughout the globe.
Well, it's hard to top what you just ran through, Mike. It really is. It's hard to it's hard to add anything to that. I think that's a nice capstone for our discussion, and I really appreciate you taking the time today to talk through all of this, and I think our audience will hopefully find this to be an interesting discussion as they try to educate themselves about the storage space. We really appreciate it. Thanks for being on the program.
My pleasure. Thanks for having me, and thank you for putting together this series of podcasts that I think helps educate all consumers and all potential customers around the art of the possible in energy storage.
I love it. Thanks, Mike. Appreciate it very much.
The views and opinions expressed in this podcast are solely those of the individual participants and not Troutman Pepper or its clients. Troutman Pepper does not make any representations or warranties, express or implied, regarding the contents of this podcast. Information on previous case results does not guarantee a similar future result. Users of this podcast may save and use the podcast only for personal or other non-commercial educational purposes. No other use, including without limitation, reproduction, retransmission, or editing of this podcast may be made without the prior written permission of Troutman Pepper. If you have any questions, please contact us at troutman.com.